class, we have finished watching your video in class about the real number system. This is your first video to be watching at home. It should be Thursday night. You're going to watch a video about scientific notation. This is part 1 with large numbers. I know you'll have another one tomorrow night, and some of you are probably thinking, well, what are we doing science in math class? Scientific notation is used in science, but it is a way to write numbers. This is a math concept about different ways that we can write numbers. During the video, please remember that you can pause and rewind as many times as you need, and then if you have any questions, make sure you write those in your composition book. When you come to class tomorrow, you'll be prepared to ask them. In your math journal, you should have your page about scientific notation. This is what it looked like before you cut it out and glued it down this morning. We're going to go through 2 sections today. We're going to go through what scientific notation is, and we're going to look at how to write numbers that are larger than 1. So these are ways to write very large numbers from scientific notation to standard form. If you will open your first section that says what is scientific notation, we're going to fill in the blanks here. Scientific notation is used to represent very large and very small numbers. So in the blanks you're going to write very large and very small numbers. It can help us write a number like the distance from the Earth to the moon. That would be a huge, huge number. Scientific notation helps us write that number where it does not look so big, and we can write it in a more concise form. It could also help us write things like how the size of an atom, which would be very, very tiny. Scientific notation will help us find a way to write that number in a more concise form. Okay, we're still under the scientific notation tab. Scientific notation always has a coefficient that is between 1 and 10. Coefficient means the number in front. So there's how you spell coefficient. Scientific notation always has a coefficient that is between 1 and 10, and it's multiplied by a power of 10. So the coefficient here is the number in the front. This number is 4.6 times 10 to the 4th power. 4.6 is the coefficient. That's the number in front. It's between 1 and 10. It may include a decimal. And then it has an exponent or a power of 10. All numbers that are written in scientific notation will look like this. It has to be the number between 1 and 10 in front, and then times 10 to a power. That number that's an exponent, that little 4, is called a power. That's an exponent. Okay, now we know that scientific notation is a way to write small and large numbers. Scientific notation has 2 parts. It has a coefficient between 1 and 10 and an exponent. We're going to look at a way to write these numbers. Today we are only focusing on numbers that are larger than 1, like the distance from the Earth to the moon would be a huge, huge, huge number. It's going to be bigger than 1. Or the number of fish in the sea would be a huge number. It's a number bigger than 1. So when we have a number larger than 1, the exponent is positive. You're in the second section of your foldable. The exponent will be a positive number. Anything that is a positive exponent means we have a big number. Okay, and now we're going to do an example together from where we change from standard form, that's how we normally see numbers, to scientific notation. So this will be your example that you're looking at underneath the very large numbers tab. We're given the number 123,547,000. To write this in scientific notation, we need to make this a number between 1 and 10. And we're going to do that by moving our decimal. The first thing you do when changing a number from standard form to scientific notation is you're going to put your decimal at the very end of the number. Right now we have 123,547,000. Our decimal in this number is after the ones place. We're going to take our decimal, we're going to move it to where we have a digit between 1 and 10. So we're going to go over 1, 2, 3, 4, 5, 6, 7, 8 places, or 8 place values, and we're going to put our decimal right here between the 1 and the 2. That gives us the number 1.23547. I don't have to put all those extra zeros because they're not significant digits. So our decimal goes between the 1 and the 2 because we need a number between 1 and 10. So we have 1 and 23,547 hundred thousandths. Now, to get our exponent, we're going to have times 10, and we've got to figure out what our exponent's going to be. The number of places that you move is your exponent. We moved 1, 2, 3. Let me try this again. We moved over. Let me get my pointer. 1, 2, 3, 4, 5, 6, 7, 8 spaces. So our exponent is going to be the number 8. So in scientific notation, we have 1.23547 times 10 to the 8th power. Remember to write this, your coefficient, your number in front, has to be a number between 1 and 10. And then our exponent tells us how many places we moved our decimal. It's a positive exponent because we started with a very large number. This is a large number, so we end up with a positive exponent. All right, be ready in class tomorrow to work on more scientific notation. You'll have your second video over scientific notation with small numbers for Friday night. You are welcome to watch this ahead of time. Just make sure you click over to video number 2 for scientific notation, and you come prepared with any questions tomorrow. Okay. To the side of your foldable or underneath it, wherever you have space in your composition book, we're going to do a couple of examples. Our first example, I'm going to give you a number in standard form, and we're going to change that to scientific notation. And then for the second example, we're going to have a number in scientific notation and change that to standard form. For our first example, the average number of hours that you have lived since you were born for an 8th grader is about 114,000 hours. We're going to take this number and we're going to change it to scientific notation. The first thing we're going to do is we're going to put our decimal at the end of the number. Now, remember, for scientific notation, we need to move our decimal where there is 1 digit in front of the decimal place. It has to be a number between 1 and 10. So we're going to move to the left until we get 1 digit in front of our decimal, and we're going to end up between our 2 ones. Now, our number looks like 1.14. We don't need to add all of the zeros. And then we have our exponent, so we're going to have times 10, and we moved to the left 1, 2, 3, 4, 5 spaces. So our exponent is going to be the number 5. So the number of hours you have lived since you were born for most of you is 1.14 times 10 to the 5th hours. Okay, remember we need 1 digit in front of the decimal when we move to scientific notation. So we've got our digit and then our decimal, and we have our exponent with the number of spaces we moved for our decimal. All right, our second example, we're going to take a look at the number of seconds that you have lived since you were born. The number of seconds the average 8th grader has lived since they were born is 4.104 times 10 to the 8th power. We're going to change this number to standard form. Now, we know that because we have a positive exponent, just like we started in our notes, we have a positive exponent, we're going to have a very large number. The number of seconds you have lived since you were born is going to be a very large number. We're going to write our number, 4.104. Now, times 10 to the 8th power means that we need to move our decimal 8 spaces. So we're going to put our pencil on our decimal. If we need to get a large number, we're going to move back 1, 2, 3, 4, 5, 6, 7, 8 spaces. Now, you'll notice the first 3 spaces we were jumping the numbers 1 and then 0 and then 4. Now we need to fill in the rest with zeros. 2, 3, 4, 5 zeros at the end because we had 5 extra spaces. So the number of seconds that you have lived since you were born is 4104 00000. Let's put in our commas so we can read this number. There's the ones, tens, and hundreds place, the thousands, 10,000s, and 100,000s place. So since you were born, the average 8th grader has lived 410,400,000 seconds.